One of the dangers which may meet the DP vessel at sea is a soliton. Soliton, or solitary wave, is a self-reinforcing wave pocket that maintains its shape while it propagates at a constant velocity. The waves are stable and can travel over very large distances. Normal waves would tend to either flatten out or stiffen and topple over. The speed depends on the size of the wave, and its width and the depth of water. Unlike normal waves, they will never merge, so a small wave is overtaken by a larger one, rather than the two combining. If a wave is too big for the depth of water, it splits in two, and one big and one small. If operating in areas where solitons are known to be prevalent, then there are a number of precautions that may be taken by DPOs. A careful watch should be kept on 3 cm radar, which might give an early warning of the onset of a soliton. Careful watch also on Doppler log to give early indication of a change in vessel speed. Position reference should be obtained from surface-oriented systems as far as possible. Additional generators should be kept online to compensate for rapid power needs with the onset of a soliton. If possible, the vessel heading should be altered into the direction from which the soliton is approaching. With the detection of a soliton, the diving operation should be abandoned and the bell recovered, or other steps taken to mitigate the effect of a position heading excursion. ROV operations should be terminated and the ROV recovered or landed on the seabed. Care must be taken when handling suspended loads underwater, crane operations, downlines, etc. DP gives opportunity to keep the vessel stable in position where anchorage not allowed during passenger transfer periods, to see some sights ashore. The characteristics of solitons are listed here. The waves radiate from a small region. They travel substantial distances. Swift currents and areas, having bathymetry-like sills on the seabed, are required for their generation. They travel in pockets, with the leading waves being of maximum intensity. They are influenced by tidal variations, sea currents, and the thermal structure of the water column. They travel at approximate velocities of 2 to 2.5 or 4 knots. Solitons in shallower waters further along the directions of travel were observed frequently, but did not appear to have the same speed of travel or effect on the positioning of vessel. This was possibly due to waves traveling from deeper water to shallow water. Solitons are observed as distinct bands of choppy water with short, steep, randomly oriented waves. They can be detected and identified in light sea conditions on a 3 cm radar up to ranges of 3 to 4 nautical miles. They are stronger in intensity during spring tides. In a particular area, they always approach from approximately the same direction. So, if you are in a situation where soliton is expected, it is recommended to abandon the DP operation safely.